Let's talk about weather and climate. Think about weather as the day-to-day state of the atmosphere. When we talk about weather changes, we talk about it in terms of the near future. How hot is it right now? What will it be like today? Will we get a snowstorm next week? People generally think of weather as a combination of temperature, humidity, precipitation, cloudiness, visibility, and wind. Now, climate is different. Climate is the weather of a place averaged over a period of time, often 30 years. So climate includes statistical weather information that tells us about the average weather and range of weather extremes for a location over a long period of time. The scientists view climate in terms of years, decades, centuries, and they study the patterns and the cycles. Climate is influenced by different factors. The one is the relationship between the sun and the earth. The other is latitude, ocean currents, and also elevation. One thing to know about climates and ocean currents is that ocean currents that are moving toward the poles, like the North Pole or the South Pole, are warm. Ocean currents that move toward the equator are cold. And then surface ocean currents are driven by global winds and play an important role in redistributing heat around the globe. The sun and earth also plays a role, the relationship between each other in the climate. So keep in mind that the earth revolves around the sun as it rotates, and you see that in this picture. Rotation does not affect season, that affects day and night, but the tilt and revolution affect the season. So when it's summer in the northern hemisphere, it's winter in the southern, and vice versa. And the axis is a little tilted. The axis is that the path that is revolving around the sun. So it's tilted, and if it were not tilted, our climate would be rather boring. Many places on Earth would not receive a lot of light. So that tilt is actually important. Another interesting fact is that the equator receives the same amount of sunlight all through the year. So there's very little change in seasons close to the equator areas. Latitude. Latitude is simply the distance from the equator. Scientists use this measure because the sun's rays hit the equator most directly. In general, the closer one is to the equator, the hotter the climate. Heat distribution. Keep in mind that the sun's heat is not static. There are forces that distribute the heat, and those forces are called convection. So warm gases and liquids are lighter and less dense than colder ones, and warm gases and liquids rise and cold ones sink. Now the movement of the air is wind, and the movement of water are currents. So you can see that in these pictures here. And as we talked about, the water currents can affect climate and heat distribution. Let's look at precipitation. Precipitation is just all forms of water that fall from the atmosphere to the earth. And precipitation forms when air temperature changes. There are three types: convectional, orographic, and frontal. So in convectional precipitation, the surface of the earth is heated by the sun, and hot, humid air rises from the earth's surface and cools in the air, and is too heavy to hold, and is released as rain. This type of precipitation is common in hot climates, like the tropics or in Florida. Orographic precipitation occurs when warm air is forced upward when passing over a high landform, such as mountains. This causes precipitation to fall before it passes over the landforms. So this is very common on the seacoast and explains why the other side of coastal mountains are frequently deserts, because they don't get the precipitation. The rain never makes its way over the mountains completely. So one side is really the benefactor of all that rain, but not the other. Frontal precipitation is the most common, and it occurs when two air masses, or two fronts of different temperatures meet. So the warm air is forced upward by the cool air that is coming in, and the warm air cools as it rises, and thus forms precipitation. And this will make more sense the next time you see the weatherman talking about a cold front moving in, which will bring about precipitation. And let's look at a chart that shows how this works. So in the first chart, you see the convectional rainfall, where sun heats the land and the air above, and then the warm air rises, cools up there, and condenses, forming clouds, and then rain can occur. In the orographic rainfall, you see the warm, moist air forced to rise over the high areas. But then it cools and condenses and forms clouds and rain. Before it can even pass over to the other side, the air descends and warms and becomes drier. That is also called a rain shadow, that side that doesn't get the rain. So in a frontal rainfall, that's the most common. You have a front indicated by the separated dashes. And on one side you have the warm air, and it's being forced to rise over cold air. And condensation forms, the clouds form, and then it rains heavily along the front. We talked a little bit about bodies of water before, and we did note that bodies of water influence climate. The one thing to remember is that land and water absorb and retain heat at different rates. Water takes longer to absorb heat and longer to lose heat, whereas changes on land can be far more rapid. So just remember in early summer when you go to the beach and the air is warm, the water is still cold. The water hasn't had a chance to catch up yet because it's slower to warm. Large bodies of water, such as lakes or oceans, can impact the surrounding climates. The wind blowing over warm water will take on the heat of the water as they blow onto shore. So here you see an example in this picture of the British Isles, and it's located far north, but the warmth of the North Atlantic current creates a more moderate climate than its neighbors of the same latitude, such as northern Canada. So certainly the currents in close by bodies of water affect the climate of a given place. Other factors influencing climates are how high and low the elevation tends to be in a given place. So Mount Kilimanjaro is near the equator, but is covered in snow year-round. This is a direct result of the impact of elevation. Air rises rapidly and loses heat as it rises, and the same goes for landforms. Thus, a landform might be tropical at its base at that low level, but covered in snow at its peak. So you see the picture of Mount Kilimanjaro here, and you have giraffes grazing in the safari at its base, but at the top is covered in snow. Landforms also influence climates. So coastal mountains can create deserts on their leeward side, as we discussed. Additionally, lakes, forests, and even tall buildings in large cities can change climates on a small scale, creating a microclimate within a larger climate. Here is a pretty good chart that depicts world climate regions. So you can see that they tend to be similar along the lines of latitude. Climates closer to the Arctic Circle are similar. Climates closer to the equator are similar. And the same is true around the Tropic of Cancer or the Antarctic Circle, Tropic of Capricorn. So you can review these images later because I'll have the presentation embedded so you can review them. So just keep in mind that changing climates are a result of changes in nature and human activity. Global warming is the observed century-scale rise in the average temperature of Earth's climate system. So since 1971, 90% of the increased energy has been stored in the ocean, mostly in the 0 to 700 meter region. This picture right here shows 10 indicators of a warming world. And you can see that in this picture that humidity has increased. Air temperatures near the surface has also increased. Temperatures over the ocean has increased. Sea surface temperature has increased. Sea level has increased. And ocean heat has increased. Now, factors that have decreased are sea ice, glaciers, and snow cover. So what do you think is going to happen with sea ice, glacials, and snow melting rapidly at a more rapid pace than earlier times in geographic history? So we'll get into that more later. So things to just think about and hopefully you've learned listening to the presentation. How does the Earth's position relative to the sun affect weather and climate? How do winds and ocean currents affect the distribution of solar warmth? Why might California's Mojave Desert have an arid climate or a desert climate? What are some possible effects of global warming? And how might global warming affect migration patterns in the future? So think about that. That's about it. Thank you for listening.